Welcome. I am Lillian Apps, and today I will be discussing the mechanistic intervention called Transcranial Direct Current Stimulus and its physiological effects on schizophrenia. Human beings are skilled with the ability to perform goal-directed thought and behavior, which includes planning future actions, overcoming habitual responses, and carrying out multiple tasks at once. Most of the cognitive processes that involve these complex thoughts and behaviors are called executive functioning. Executive functioning can be found through dynamically adjusting and regulating behavior from internal representation and feedback from the environment. Another essential neuropsychological function is the working memory. This can be defined as a limited amount of information that is easily kept in mind temporarily and is used to carry mental tasks such as solving problems and making decisions. Schizophrenia is a disabling disease in which the individual will experience altered thoughts, perceptions, emotions, and behaviours. Individuals with schizophrenia exhibit executive functioning and working memory deficits. Recent meta-analysis have found that dysfunctional working memory and executive functioning in individuals with schizophrenia can be caused by abnormal brain activation in the frontal cortex. Minzenberg and associates found that this includes the medial frontal gyrus and the anterior cingulate cortex, which are frontal cortical regions that are subserving working memory and executive functioning. Observed changes were found from the regional prefrontal cortical activation in schizophrenia. This leads to potential mechanistic interventions such as transcranial direct current stimulus. Transcranial direct current stimulus can be defined as a non-invasive brain stimulation technique where low-intensity currents are applied to the scalp through electrodes. This brain stimulation can moderate cortical excitability and briefly increase brain plasticity. Reinhardt and colleagues found through the robust effects of a nodal transcranial direct current stimulus in improving cognitive performance in both healthy subjects and individuals with neurodegenerative disorders help support its use. A study done by Orlov and associates found an increased activation at the site of a real transcranial direct current stimulus anode, in comparison to a placebo, in the medial frontal cortex during working memory tasks. The data demonstrates differential task-dependent effects of behavioral performance in those who have schizophrenia. This data supports previous findings which show how improvement through transcranial direct current stimulus in executive functioning can be immediate, yet improvement in working memory is only observed after a consolidation period. This study also found that activation in the left medial frontal gyrus and nodal from transcranial direct current stimulus resulted in an increased activation in the cortex at the site of the anode. As a result, with activation, working memory and executive functioning could improve for individuals with schizophrenia. This correlates significantly with improved working memory performance after a consolidation period. Improved performance on executive function inhibition tasks were also associated with a nodal transcranial direct current stimulus, which found reduced activation of both anterior cingulate cortex and the cerebellum. Another study by Orr and associates establishes how transcranial direct current stimulus could help individuals with schizophrenia with improved cognitive processes. The study involved participants receiving stimulation from either right prefrontal, left prefrontal, or a placebo situation with concurrent visuospatial WM training over a course of 7 training sessions. The results successfully showed that transcranial direct current stimulus enhanced performance, increasing working memory and executive functioning. Therefore, through transcranial direct current stimulus, the poor functional outcome of schizophrenia that allow for working memory and executive functioning deficits can be intervened based on the neuromodulation through frontal activation. Thank you.